Hey everyone, hope you're all doing great. As the title says, in this video, we are going to cover the most important, difficult, and common questions from Chemistry Unit 1, the ones that show up again and again in exams. This is part 1 of a two-part series designed to boost your confidence and exam performance. So without wasting any more time, let's jump straight in. The first question, it says about the isoelectric ions N3 minus, O2 minus, F minus, Na plus, Mg2 plus, and Al3 plus. The question is which ions are shown in the order of decreasing ionic radius. Now decreasing basically means largest to smallest. In other words, we need to identify the largest ionic radius ion, and then the last one will be the smallest one. Now if we see right here, among all of them, we can clearly see Al3 plus has the highest charge. Why? Because it has lost 3 electrons lost. Since 3 electrons are lost, the force of attraction is between the remaining outermost electrons and the nucleus is the highest, which results to the lowest ionic radius of Al3 plus compared to its counterparts. So in that case, Al3 plus will have the smallest ionic radius. Now, if we check out C and D, obviously Al3 plus is provided at the as the first option, which is obviously wrong. So this leaves us to A and B being any one of the correct answer. Now A is the answer. Why? Because if you see right here that if you compare Na and Mg, you can clearly see that magnesium has a higher charge, which basically means that 2 electrons have been lost, meaning that the force of attraction in the magnesium ion compared to sodium is higher. The reason why it has a lesser ionic radius compared to Na plus. So this would be the correct order of decreasing ionic radius being shown. Moving on, which ions are shown in the order of increasing ionic radius? Now this is a crucial one. Basically they're trying to say we need to identify the smallest ionic radius to the largest. All right. uh, Now it is just the opposite of the previous question. Now you have been provided the anions right here. You can clearly see that nitrogen here, the nitrogen ion right here, it gains the highest number of electrons. In other words, it has gained 3 electrons. So due to the gaining of 3 electrons, it will experience the greatest shielding effect or the greatest amount of repulsion from the electrons present at its inner shell, which will result to an increasing ionic radius, or it will cause the outermost electrons to get loosely attracted to get more loosely attracted towards the nucleus, hence in other words increasing the ionic radius. So if you compare that, nitrogen anion is supposed to have the highest ionic radius, so automatically C and D will be out of our option, as well as B. A would be the correct answer. And now F minus and O2 minus, this priority or trend also makes sense, because if you see, oxygen is gaining 2 electrons, while compared to fluorine, which has gained only 1 to produce this. So obviously the attraction between the nucleus and the outermost electrons of O2 minus is going to be lower, so for which the ionic radius compared to F minus will be higher for O2 minus. So the correct trend would be A. So A will be our correct answer. Moving on, let's say the question is about silicon. Now define relative atomic mass. You can clearly see what is the relative atomic mass according to a nice definition provided: the weighted average mass of an atom of an element compared to 1/12 the mass of a carbon 12 atom. So what they're trying to say is that whenever we try to find the relative atomic mass of something, it basically means it is the average mass of that atom, or in other words, it is the average mass. In case of silicon, the relative atomic mass is basically the average mass of a silicon atom compared with and this mass which of this atom in the element is always compared to a to the 1/12 mass of a carbon 12 atom. That means whatever the mass of a carbon 12 atom is, we will compare the 1/12 of that mass with the weighted average mass of an atom of any element. So instead of silicon, it could be carbon, it could be fluorine, it could be oxygen, it could be nitrogen, it could be anything. All right, let's move on to the next part. Moving on, another question. It says, consider the elements aluminum, silicon, phosphorus, and sulfur. Now explain the trend in the first ionization energies of aluminium, silicon, and phosphorus. As provided, it is written here that the first ionization energies increase for aluminium, silicon, and phosphorus because the electrons being removed comes from the same subshell, so they experience the same shielding. So we know that three of these elements have an electronic configuration with their outermost electrons being present at the outermost electrons are removed from the same subshell. Since three of them are present at the same period, in other words, three of these are present in period 3, so three of them will have the same number of shells. So if we just write down the electronic configuration of these three, so for aluminum this is 13, for silicon it's 14, and this 15. So it would be 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 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 3p1, and that's 3p2, and that's 3p3. So as you can clearly see that from the same subshell, or that from the same 3p subshell, the first outermost electron is getting removed. So as a result, since all of the outermost electrons exist at the same subshell, they are going to experience the same amount of shielding from their inner subshell electrons. All right. So as a result, we can say this is one way. And another thing is that you have to say that the number of proton increases as we go from aluminium, silicon to phosphorus. And we know that period wise, if you go from left to right, the number of protons or the atomic number increases. So due to the increasing atomic number trend, what is happening? The nuclear charge is increasing. Phosphorus is the highest nuclear charge compared to aluminium and silicon, and so on, silicon, so forth. So as a result, if the nuclear charge increases, the outermost electrons are going to be more strongly attracted towards the nucleus. So hence, more energy will be required. So this is the main reason why the first transition energy of aluminium, silicon, and phosphorus increases due to the increasing nuclear charge. And another thing is that the shielding effect is not taken into consideration because three of them are going to face the same amount of shielding from their inner subshell electrons, considering that all of their outer electrons are present at the same subshell. So without considering the shielding factor, the nuclear charge factor is taken as a higher priority, for which the ionization energy, the first ionization energy specifically speaking, increases for three of these elements provided. Now they said explain why sulfur does not follow this trend. Now you have to understand this. As they said here, that in sulfur there are 4 electrons in the 3p subshell, and the electron being removed is from a full 3p orbital that is being paired. So yes, there is a repulsion between the paired electrons. So if you check out sulfur electronic configuration, you have 1s2, 2s2, 2p6, 3s2, 3p 4. All right, now you have to understand one thing, that when you try to draw, if you see, we know that there are 4 orbitals in a p subshell, right? 1, 2, 3, 4. All right, so if you just check it out, so if you see that, you can clearly see that there is one electron right here present at the sulfur atom. Now you can clearly see that that is paired. So one of the electron, as you can see, the fourth outermost electron is kind of in a paired state. So due to the paired state, it is going to experience repulsion, more repulsion. So since it's going to face repulsion due to one of the electron being present in a paired state, so due to this repulsion, lower the energy required to remove this electron will become lower, because the unstability will decrease. The unstability will decrease. So this is the reason why, due to this repulsion, the electron being removed from the 3p orbital will have a lower ionization energy. So that is why sulfur is basically an anomaly, compared when you follow the trend period wise from aluminium, silicon to phosphorus. And that is the reason why sulfur is has a lower ionization energy compared to phosphorus, although it was supposed to have higher ionization energy than phosphorus, but it does not. Moving on, using the simplest alkene as an example, draw the mechanism to show the reaction with bromine. Now we know that when alkene reacts with bromine, it follows a mechanism called electrophilic addition. So what happens is that at first, via heterolytic fission, one of the bromine atom, or one of the halogen present in this case bromine, obviously. So one of the negatively charged bromine basically takes all the electrons, the bonded electrons, and this causes the Br bond to break down. And when does this happen? When the whole when this basically acts as an electrophile, when this acts as an electrophile and approaches the double bond, where it basically experiences repulsion, and since it experiences repulsion as it comes closer, the Br basically bonds break down by heterolytic fission, and then this results to the production of carbocation, as you can see, because one of the Br which is broken down by heterolytic fission tends to join with one of the carbon right here. Now what we see is that a carbocation is produced. Now obviously we know that carbocation is an unstable form of an intermediate compound. It's an intermediate compound basically. So, and any intermediate compound is kind of unstable. So obviously the one which is broken down, the negatively charged bromine atom, is going to attack the carbocation, and it will result to the production of 2-bromo ethane. So this is how it works. Moving on, explain the meaning of trans in trans fat using a skeletal formula showing 4 carbon atoms in your answer. So any whatever you draw, try to please show that there are at least 4 carbon atoms. And trans basically means alkyl groups are either side of the bond. So meaning that, as you can clearly see, this is an alkyl group, that's an alkyl group. These alkyl groups, if they are present on different sides of the double bond, then they are known as trans. All right, and if they're present on the same side, then they're known as cis. So this is what the difference between cis and trans basically means. Moving on, which statement is about polyethylene is not correct? Now polyethylene is not correct. It is an addition polymer, a kind of, it is not an addition, it is kind of addition polymer. So this is the correct statement. It is non-biodegradable. Yes, it is non-biodegradable. It has an empirical formula of CH2. It does have an empirical formula of CH2 when you try to formalize or simplify the main molecular formula. So the only answer is this: it decolorizes this is not the correct answer, because as you can see, what is B statement? It decolorizes bromine water. Polyethylene doesn't have a double bond. So the main reason why B is wrong, because this statement relates to the test of unsaturation, and since polyethylene does not contain, polyethylene structure is this, which means it does not consist of any carbon to carbon double bond, it does not necessarily decolorize bromine water. So B is not the correct answer. Moving on to the next part, the carbon to carbon double bond consists of a sigma and a pi bond. Describe the difference between the sigma and the pi bond and include a labeled diagram in your answer. So they said here, down here, as you can see clearly, that if you want to draw the sigma and the pi bond. Now we know that the sigma bond is produced by the end on overlap. We know that sigma bond is formed from an end on overlap of p orbitals, while the pi bond is produced by the sideways overlap of the p orbitals, like perpendicularly, like this. So this is how you can this is the this is one difference you can say. This is the main difference basically between sigma and pi bond. And but there is one thing you need to remember, that is, whenever pi bond is produced, a sigma bond is always produced, meaning that whenever there is whenever in the presence of a double bond, one of the bond is supposed to be a sigma bond while the other tends to be a pi bond. Okay, let's move on. Give 2 reasons why compound A and compound B exists as geometric isomers. Now, geometric isomerism is only possible due to the presence of carbon to carbon double bond, because there is restricted rotation around the double bond. Compared to a single to single carbon bond, a double bond has unrestricted rotation, meaning they cannot simply whatever atoms are connected around this carbon, they cannot simply just change their position by through rotation, because they face unrestricted rotation within the axis where the double bond is present. But in the case of carbon to carbon single bond, it is possible for the whatever element is present here and whatever element present, it is kind of possible to change their positions, because there is unrestricted rotation down here compared to here where there is restricted rotation. So since there is unrestricted rotation, meaning that the whole carbon to carbon double bond can be rotated anti-clockwise or clockwise, anyhow independently. So we can say that geometric isomerism cannot, is kind of impossible in carbon to carbon single bonds to exist. So as a result, we can say, and that's one thing, unrestricted rotation is one condition, and another condition is that for a double, for compounds A or B or whatever compound it is, C or D, for geometric isomerism to present, one of the condition is restricted rotation, another one is that each of the carbon present in the double bond must have two different groups being attached. That means both of them cannot have A attached to them easily. It doesn't work that way. So in other words, what they're trying to say, that let's say for instance this one down here, if each carbon consists of the same two same groups attached to one of the carbon, then geometric isomerism is not possible. Geometric isomerism is only possible when each carbon will consist of two different groups attached to it. All right, so this is how it works. It could be A or it could be B, like this. It cannot be AA or it cannot be BB, because if the same groups are connected to this, to each carbon atom, the geometric isomerism is not possible. So this is the two reasons why A and B will exist as geometric isomerism, because it is a double bond and it is restricted rotation and it has two different groups attached to to each carbon in the double bond, as you can see clearly. Yes, as we can see, uh, here there is H, so that's A, and this is B, this is A, and that's B for you. So if there was CH3 attached to this carbon, then geometric isomerism would not have been possible. 2-chloropropane can be produced by reacting propane with chlorine in a homolytic free radical reaction. Now, this shows the initiation step of this reaction include the inappropriate errors in the condition. Now, we know that in a free radical substitution reaction, the first step in the mechanism is initiation process, where the halogen bond tends to break down via heterolytic or homolytic fission. Now, obviously, whatever fission takes place, the UV radiation must be present. So, for homolytic fission to be present, UV light is necessary. That means, in the presence of sunlight, this reaction or this process takes place. This results to the production of radicals, which are literally species consisting of unpaired electrons. Now, what is meant by the terms homolytic and free radical? As I said a little while before, a species with an unpaired electron is a free radical, and homolytic, and difference between homolytic and heterolytic is that both of them are bond breaking process, but it's just that in homolytic, each atom gets one electron from the even splitting to produce two free radicals, while in heterolytic, the opposite happens. Say, for instance, HCl, the higher electronegative element, in this case chlorine, is going to receive the electrons from the splitted covalent bond to produce uh, one free radical. This is the difference between heterolytic and homolytic fission. Next part, just it suggests why this method has limited use in the synthesis of organic compounds. Now, further substitutions can occur in excess halogen, which then form more waste products. Yes, it can also happen is that after the main reactions in the further in the substitution has taken place, more further reactions might take place if the amount of halogen is in excess. So this might result in the production of other products, or which could be potentially used which could be potentially waste, or won't be required by the industry. So that is the reason why this method has there is a limit of for this method when it is used in the synthesis of organic compounds at the industry, because the presence of excess halogen can produce waste products, and this also increases economic costs as well. True chloropropane can also be produced from the reaction of propene with hydrogen chloride. They told you provide the mechanism for this reaction and include curly arrows and relevant dipoles and lone pairs. Now it's the same as the previous mechanism. A little while back we showed that again, in this case obviously via hydrolytic fission, again the higher electronegative element, as we can see down here, takes in the electrons from the covalent bond and breaks itself, while the H plus tends to get attracted towards the negatively charged carbon to carbon double bond, and one of the bond breaks down in order to accommodate this H plus. Now once the one of the bond breaks down, intermediate carbocation is produced, and so the remaining radical the which has been produced tends to react towards the positively charged carbocation right here, and again joins together to produce the final product here. So this is how the mechanism is shown with the relevant dipoles. These are the dipoles and these are the arrows which are shown. Remember one thing, the H plus is attracted by the carbon to carbon double bond here. So ensure that the arrow direction is shown towards the H. Explain why a small amount of 1-chloropropane is produced in this reaction. Now, this is a nice question. You have to understand one thing, that there are two ways this reaction may proceed. One is the carbocation can be produced right here, while another carbocation could be produced down right here. So there are two carbocations. The only difference is that this is a secondary carbocation and that's a primary carbocation, considering this carbon is attached to one carbon and this carbon is attached to two carbons. So we all know that this is the trend of stability for carbocations, where a third degree is more stable than second, and so on and so forth. Now, why 1-chloropropane is produced in this reaction in very small amount? Because this is where the answer is related to. Because in simple words, the second degree carbocation which has been produced here compared to here, this is also produced, but they did not show you here. But this is also produced, but this is a first degree carbocation. But since the second degree carbocation is more stable compared to a first degree carbocation, the chlorine which is going to get attracted and produce this final product will be major in amount compared to the chlorine which gets attracted towards this carbocation, primary carbocation right here, which is produced. So what the 1-chloropropane will be minor in amount. So this is the reason why basically due to the stability of the carbocation, since 1 degree carbocation has lower stability, this is the reason why 1-chloropropane is produced as a minor product compared to 2-chloropropane. The formula of boric acid can also be written as BaBOH3. That is to draw a dot and cross diagram for this molecule and to show the outer electrons only, and suggest a value for the OBO bond angle. So justify your answer. Now, if they tell you what will be the value of the OBO bond angle, you need to at first identify the number of bond pairs. So we can clearly see there are 3 bond pairs right here, and since there are no lone pairs, the repulsion will be less. We know that if you just compare it with one of our previous knowledge from AS chemistry, where we have seen BF3. Again in BF3 also we have seen the angle was 120 degree between the bonds, since 3 bond pairs and no lone pairs. So again, this OBO's bond angle would be 120 degrees. Why? Because obviously we can clearly see there are 3 bond pairs and no lone pairs. So obviously this would result in the production of a trigonal planar, and trigonal planar always tends to provide a bond angle of 120 degree. Otherwise, a shape of a trigonal planar is not possible. And why 120 degree? Because the electron pairs always try to arrange themselves in such a way so that maximum separation and minimum repulsion is experienced between them. And to produce a trigonal planar, so that they can experience minimum repulsion between them, a bond angle of 120 degree is necessary. Moving on, what types of bonding are present in the compound ammonium chloride? So the question is, in NH4Cl, if you basically draw the bonds right here, you have NH4 plus and Cl minus. So since both of them here consist of a cation and an anion right here, so we know that an ionic bond is definitely going to be present. one thing gone. Now if I talk about covalent bond, so we can see that here in the chlorine also, chlorine is itself consists of covalent bond within itself, and on the other hand, in case of NH4 as well, there is a covalent bond between hydrogen and nitrogen, keeping them together. So in that case, the covalent bond is also present here as well. Now if I talk about dative covalent bond, what is dative covalent bond? Dative covalent bond is basically the covalent bond which is basically produced between two groups of atoms, where one group consists of an empty orbital while the other group consists of a lone pair of electrons. And now in this case, obviously ammonia has a lone pair of electron which it can donate to one of the empty orbitals of chlorine to produce a bond, and this bond is known as dative covalent bond. So in other words, we can say that dative covalent bond is also present. So yes, D is the correct answer. Moving on, the electronic configuration of the atoms of four elements are shown. Now, what is the electronic configuration of the atom of element which has the lowest first ionization energy? Now, in order to identify this, we need to check out all of the electronic configuration right here. Look, if you check out right here, the outermost electron is in an orbital closer to the nucleus. That's right. If you among the four of them, we can clearly see this is the most closest toward the towards the nucleus. So as a result, we can say the force of attraction between the nucleus and this will be the highest, and instead of lowest, it's going to require the higher it's going to require the highest first transition energy. So yeah, A is not the correct answer. If you check out C and if you check out B, here the even though the nuclear charge is greater, yes, obviously the nuclear charge is obviously greater than this, the thing is the outermost electron is kind of is the same subshell as B. So there is stronger attraction. So since they're in the same subshell, so yeah, they're going to receive the higher ionization energy. And if you talk about this one as well, in the case of these three, these three, all of them are present in the same, the outermost electrons are present in the same subshell, and they're going to receive the same shielding point. But the main point here is that the attraction here is that it's going to be stronger because the outermost electron is in the same subshell. So obviously the energy a higher heat energy will be required to break the force of attraction between the nucleus and the outermost electron. So in other words, we can say the lowest first transition energy would be B, because this basically contains the lowest nuclear charge, and obviously it has only one electron in its p subshell. So that is main reason is basically it has the lowest nuclear charge. That is why B is the correct answer. Alright guys, I hope everything's been clear so far. If you're enjoying this and want to practice more papers or complete the syllabus with me before your exam, here's something for you. At Exam Essentials, we offer 2 signature courses before every session. The question paper marathon course, perfect if your exam is within 2 months. And of course, then there's the high impact crash course, which is ideal for those with 3 to 6 plus months to go, focused on full concept coverage and strategy. Course details are in the description. You can also message us directly via WhatsApp at the number below, or reach out on our Facebook page, Exam Essentials. Let's make your preparation smarter and stronger. A direct electrical current was passed through a green solution of copper to chromate 6 in the apparatus shown. So you can see it right here. Now question is, which colors could be seen at each electrode after several minutes? Now if I talk about copper 2 ions and chromate 6, the copper 2 ions are going to go towards the negative electrode. So we know that copper 2 is blue in color, and chromate 6 here, CrO2 minus, they are going to move towards the positive electron because they are negatively charged. So that is going to be yellow. So because we know chromate is yellow in color, the color of CrO2 minus is yellow. So in other words, we can say C is the correct answer. Now, in which region of a mass spectrometer are particles ionized? Now, this is a nice question. You have to check out the regions P, Q, and R right here. Now, in region P, it is not, because in region P the sample is vaporized. Yes, in region Q there is there is the region Q is known as the ionization chamber because it consists of an electron gun which tends to shoot electrons towards the vaporized sample, and the molecules present in the vaporized samples tend to collide with these electrons, and this results to the atoms in the vaporized sample being ionized. So yes, region Q is the correct answer. In case of R and S, S is where the ions are detected, while R is where the ions basically receive acceleration, or receive a force due to the presence of an electric field. Now, this question is about the elements in period 2 of the periodic table. Now, the first ionization energy of some elements in period 2 are shown. They said here, explain the general trend in the first ionization energy across period 2. So if you check out across period 2, now there is a general increase in first ionization across period 2, because obviously the first things first, the number of protons increases. Now, uh, the number of protons increases, but since they're in the same period, the electrons which are removed, the outermost electrons which are removed, they're removed from the same shell, so they basically experiences a similar shielding. Now, since the number of proton factor increase, the increased nuclear charge kind of overcomes the shielding effect, so we can say the general increase is that ionization energy increases across periods because of the increasing nuclear charge, causing the force of attraction between the outermost electrons and the nucleus to increase, so more heat energy is required to remove the outermost electron. Now, predict a value for the ionization energy of oxygen and justify your answer. Now, this is very nice. Now, according to the general trend, it is supposed to have an ionization energy greater than nitrogen, but it's not. It's going to have something like 1300, way less than nitrogen's 1402. Now, this is because the electron, which is is removed from a full 2p orbital that is paired, while in nitrogen the electron is from a singly occupied orbital that is unpaired. Now if I talk about nitrogen, it is 14, and we know for oxygen it is 16 down here, if you know the rules basically. Now if that's the case, if we see that there is 7, that's 8 for us. So if you do it, we have 1s2, 2s2, 2p3. So they're trying to say the 2p electrons present in the nitrogen are present in an unpaired state, but in the case of oxygen, if we talk about in the case of oxygen, there is one extra electron in their 2p subshell, meaning the electron is present at a paired state compared to the electrons which are present here, all of them in an unpaired state. Now since they're present in a paired state, this kind of makes them stable. This is the more stable form of of the electrons being present in the subshells, or arranging them. This is basically the more stable form of electron arrangement in any subshell, where all of them are present in unpaired state. So why they are stable? Because they're experiencing very less repulsion. But whenever any one another electron, for example right here, is introduced, let's say here, if one electron is introduced, then the instability increases, or in other words, the stability decreases, considering the electron which is in the paired state tends to experience repulsion. So that is what happens between, if in oxygen, where where there is one more electron compared to nitrogen. So that is the reason why nitrogen, the energy required to remove an electron from oxygen is going to be less compared to an unpaired electron, that is between the as there is repulsion between paired electrons. So this is the reason basically. If something is more stable, so more heat energy will be required, and if something is less stable, or due to the repulsion, in this case obviously oxygen is less stable because of the repulsion down here, so less energy will be required to remove that electron. So that is why oxygen has a lower ionization energy than nitrogen. Now explain the large difference between the first and the second ionization energies of lithium. Now, the second ionization energy is greater because the second electron being removed is from an inner quantum shell uh, that is closer to the nucleus. So the electron is more strongly attracted to the nucleus, and that is why obviously ionization energy is required to remove the electron. Now that is a nice answer, because if you check it out, the large difference between second of lithium, we know what? We know that lithium has 3 electrons. So in other words, it is 1s2, 2s1. So you can see clearly that after the first electron is removed, the second obviously is going to be higher because they are because the second electron is present in 1s subshell, which is obviously an inner quantum shell. So obviously the attraction, the distance decreases between the nucleus, and so the attraction will be higher. And if the force of attraction is higher, more heat energy will be required to overcome that force, and that is why ionization energy increases in lithium. If you check out the next question, they say that beryllium reacts with fluorine to form beryllium chloride in the gas phase. Now, the beryllium chloride exists both as a simple molecule BeCl2 and as a dimer. They told to draw a dot and cross diagram of the molecule BeCl2 down here. So that is what how it is. We know that chlorine has 7 electrons in an outermost shell, while on the other hand, we have beryllium, which has 2. So, in other words, beryllium, which is 2. So we can clearly see there's the 2 electrons from beryllium, and while chlorine provides a respective 1 electron to basically fulfill the shell. So that is what BeCl2 is. Now obviously this is going to be a linear shape, and the bond angle for any linear shape, for instance for carbon dioxide as well, is going to be 180 degrees. Now why is that the case? This is because there are 2 bonding pairs and there are no lone pairs of electrons, and for linear shape to happen, you require 2 bonding pairs and no lone pairs. So that is the reason. And why the linear shape happens? Because when there is 2 bonding pairs and no lone pairs, the electron pairs can arrange themselves in a linear way so that they can experience maximum separation, which can result to minimum repulsion between them, according to VSPER, valence electron share pair electron shell pair repulsion theory. Now, the next question, they said draw a diagram to show how 2 beryllium chloride molecules bond together to form the dimer Be2Cl2, stating the type of bond involved. So, obviously, chlorine and beryllium down here, chlorine basically consists of lone pair of electrons, consists of a lot of lone pair of electrons, while the beryllium down here consists of two empty orbitals, specifically speaking. So, obviously, what's going to happen is that, or at least one orbital. So since there are 2 orbitals completely free, so obviously the one of the lone pair of electrons in protein is going to just occupy one of the orbital, and this would result in the production of a covalent bond called dative covalent bond. Dative covalent bond is just a specialized version of covalent bond, where empty orbital and lone pair of electron is required to produce it. Moving on, again you can see hexane will react with chlorine in the presence of ultraviolet light to form a number of products. Describe the role of ultraviolet light in the initiation step of this reaction. Now obviously why the UV light is required in the initiation step is pretty simple. A little while ago we have experienced the same type of question in October 24, and this is October 23 as you can see, but it's just that they told you, instead of answering about homolytic or hydrolytic, they have now told you why they've now asked why the UV light is required. See, the UV light is kind of required to provide enough energy to break the CCl bond in order to produce 2 chlorine radicals. This is the reason why UV radiation is required. Now, again, the alkane dodecane, they told you to write the equations for the propagation step and for the termination step. In case of propagation step, what happens is that, again, the radicals which have been produced in the initiation step, they tend to react with the other reactant present in the halogen alkane reaction. So in this case it reacts with the alkane, which results to the production of another radical and obviously the corresponding hydrochloric acid, where one of the H comes out and reacts with Cl. Again, this radical which is produced reacts with the remaining chlorine which hasn't gone through the hydrolyte initiation process, and tends to produce the real desired product, which is the halogen alkane that will be required. Now, whatever radicals are present that have been produced in the initiation and propagation step, they tend to react together during the termination step to produce the final product. So, in other words, the termination step ensures that no radicals are left at the end of the reaction. Now, if you check out the next one, which compound has the greatest covalent character? All right, if for covalent character, to judge a covalent character, we need to at least check out the electronegativity difference down here. Now obviously we can clearly see the electronegativity we know increases the period, and we know it decreases down the group. So if you check out magnesium compared to sodium down here, magnesium obviously has a higher electronegativity compared to sodium, because it's present, right side of the period compared to sodium. But if I talk about fluorine and bromine down here, obviously fluorine is going to have a higher electronegativity compared to bromine, considering it is above in the groups. It is above, bromine at group 7. So obviously this is going to receive, so obviously since this has a higher, this is high and this is low, so obviously the difference between high and low will obviously be least. The difference will be least compared to the other compound. So since it has the least electronegativity difference, obviously it's going to have the greatest covalent character. Because if the and vice versa, basically, like if the electronegativity difference is high, then obviously it's going to receive the lowest covalent character, or in other words, higher ionic character. Moving on, they said here which has the smallest ionic radius. Now, for smallest ionic radius to happen, we need to at first check out, we need to at first omit D and A from our options, because obviously they are gaining electrons. Obviously they will have a higher ionic radius. Now if you compare Mg and Na, obviously this one loses 2 more electrons compared to sodium. So obviously this cation is will be smaller than the sodium ion, because obviously 2 electrons are being lost. So force of attraction is going to be higher in the outermost of the remaining outermost electrons in magnesium compared to sodium. So B is the correct answer. Moving on, they said here which property shows a general decrease down the periodic table from sodium to chlorine. Now, a general decrease will obviously be atomic radius, because obviously electronegativity increases if we, across the periodic table. They're trying to say from sodium to chlorine, so basically they're trying to say across the period. Yes, atomic radius decreases because due to the increasing nuclear charge. Electronegativity increases, not, it does not decrease. Fast transition also increases due to the increase in atomic radius, and also so due to the decrease in atomic radius, sorry. And obviously melting temperature is supposed to increase because there is the increase in nuclear charge. So yeah, atomic radius decreases, so obviously melting temperature is supposed to increase as well, because the ionic bond becomes stronger. Now the first transition energy of sulfur is lower than that of phosphorus. Why is the best explanation for this? Now this is not the correct answer. The atomic radius of sulfur is greater than that of phosphorus. No, that is not the correct answer, because we clearly know that sulfur is, no, sulfur has a lower, the sulfur has basically a lower ionic radius than that of phosphorus, so the atomic radius than phosphorus, so that is not the correct answer. If you check out the electronegativity of sulfur, yeah, electronegativity tends to increases. So in that case, since for sulfur is present at the right side, so electronegativity is supposed to be greater than that of phosphorus, but this kind of electronegativity is not a factor which kind of hampers the first transition at the the lowering or the uppering of first transition energy. So that is not taken into consideration. This leaves us C and D. Now the repulsion between outer electron and sulfur is greater than a phosphorus. Yes, it kind of makes sense, because sulfur obviously the has a higher nuclear charge. That means it has higher number of inner shell electrons. So that kind of increases the shielding. So this is the reason, the due to the shielding, the repulsion will be higher in sulfur compared to phosphorus. That is why the ionization energy will be lower for uh, for sulfur compared to phosphorus, considering the due to this repulsion being faced, the outermost electrons force of attraction between the nucleus will decrease, and as a result less heat energy will be required to remove them from their structure. They said here the next one, the structure is about the mass spectrometry and the shape of the molecules. In the mass spectrometer, vaporized atoms are ionized in the ions formed are accelerated, deflected, and detected. State how atoms are ionized in mass spectrometer. Now, obviously, a little while ago we have seen the diagram. So, in this case, we just need to explain it in words. Again, vaporized atoms are ionized by by being bombarded with high energy electrons. That's right, using an electron gun. High energy, in other words, high kinetic energy electrons are bombarded towards the vaporized sample, and as a result they collide with the molecules of the, or the atoms of the vaporized sample, for which this results to one of the electron being being lost from those vaporized sample atoms, and hence producing ions. Now for ions to get accelerated, and since ions are charged, they need to be taken into under the presence of an electric field or under the influence of an electric field. So obviously the ions are basically accelerated by an electric field. That's how it is done. Now explain why isotopes of elements have the same chemical reaction but their ions are deflected differently. Now it kind of varies. The deflection from the magnetic field from by the ions kind of varies depending on their mass to charge ratio. Imagine they have the same charge. Here m is the mass and z is the charge. Imagine they have the same charge but they have different mass. So if someone's mass is lower, overall mass to charge ratio decreases. So in other words, they are going to receive, they're going to receive, they're going to basically receive less deflection, and lighter ones, in other ones, sorry, they're going to receive more deflection, while the heavier ones, they're going to receive less deflection, because if the mass increases, the whole ratio increases, and so the deflection kind of decreases. This is how it works. It's written in the note section. State what is meant by the relative atomic mass. A little while ago, we have experienced the same question in 2024 May. So this is the same answer basically. Moving on, the mass spectrum of phosphorus trichloride is shown. So phosphorus has only one isotope down here. You can see they're told to complete the table to show the ions responsible for these peaks. Now you can clearly see down here that chlorine, for the formula of ion for 101 down here, it's going to be phosphorus, chlorine, chlorine. There is three formulas, and the relative peak height would be 961. Because you can please, how will you understand this? Because check this out. If you check out this combination, if you add these three of these relative atomic mass, you tend to get 101. So by handling the by checking out carefully, understanding the combinations, we can write the answer, the formula of the ion, according to the mass to charge ratio provided down here. Now they told you to draw the diagram, proton cross diagram of PCl3 molecule, and to show the outer electrons. It's just like the previous one where we drew PeCl3 atom. So again, you basically take in consideration of the outer electrons of phosphorus and chlorine and draw the proton cross diagram for PCl3 molecule. Now you have to explain, whenever they tell you to explain the shape of any molecule, again it's the same thing. You need to talk about the VSPER theorem, where you, why it is the PCl3. Obviously PCl3 is going to have a trigonal pyramidal shape. Why? Because in this case it's going to be trigonal pyramidal, not trigonal planar, because now there is one lone pair, three bonding pairs. If it had three bonding pairs and zero lone pairs, it would have been just like previous question we have seen, it would have been trigonal planar. But now since this is one lone pair, it is going to be a trigonal pyramidal, just like ammonia, where we know that there is one lone pair present in its structure. So again, due to this, the electron pairs arrange themselves into a position, and that position is trigonal pyramidal. And why this position? Because they'll get to experience maximum separation and minimum repulsion. And yeah, now why this all thing happened? Because due to the presence of lone pair, and since we know that lone pair bond pair repulsion is greater than bond pair, this is the reason why they basically arrange themselves in a trigonal pyramidal shape. Moving on, the said here, barium chloride has a melting temperature and cesium has this. Explain, you have to consider the ions involved. Now you need to understand one thing. Both of them are ionic compounds, so obviously there is no question of intermolecular forces down here. So if you check out, Ba2 plus obviously has a higher charge than Cs plus, so obviously it's going to have a lower ionic radius, because so yeah, Ba2 is smaller than Cs plus. Now, due to the higher charge density than Cs plus, obviously the electrostatic force of attraction between the ions will be greater in BaCl2. Yes, due to the higher charge, the force of attraction for Ba2 plus between this and and the Cl will be obviously higher than the cesium plus and the Cl ions. So obviously, since the force of attraction will be higher, more heat energy will be required to break the ionic bond in BaCl2. So that is why the melting temperature is higher in BaCl2 compared to CsCl2. Now, moving on to the next part of our question. Okay. again, graphite electrodes are used in the extraction. Now they told you to basically explain the structure, how the structure, the bonding in graphite makes it suitable for this application, and you need to refer to the diagram in your answer. Now again, we have learned this a long time back. So we know that the graphite is a giant covalent structure where each carbon atom is covalently bonded to three other carbon atoms. That's right. You can clearly see that each carbon atom is kind of bonded with three others carbon atoms, right? So obviously we know a carbon can maximum produce four, right? So since three bonds are produced, one of the bond basically is not produced. As a result, one electron remains free per carbon atom. So now these free electrons get delocalized, and they can now basically, which means they can basically flow freely throughout the structure and carry the charge whenever a potential difference is applied. So as a result, since the electrons are delocalized to carry the charge, so when potential difference or in other words the voltage is applied, these electrons can carry the charge. And this is the reason why graphite is, it has a high conductivity. On the other hand, it also has a high melting temperature. Why? Because there is a, there is very strong covalent bonds between the layers. This layer 1, layer 2, layer 3, all of these bonds are covalent bonds, and each of the carbon atom are bonded with strong covalent bonds. So obviously a high amount of heat energy is required to break them. So that is why they have a high melting. So graphite, in other words, we can say, is also very rigid and strong. So these are the main features which make it suitable for graphite to be used in the extraction of aluminum, because you can clearly see in the extraction of aluminum high melting temperature is required. So so obviously, since graphite is a high melting temperature, it won't easily melt so easily. And while it is also, it has electrical conductivity as well. So since it is an electrical conductivity, the molten cryolite can also be, so the electrolysis of Al2O3 can also be performed as well, because the graphite will act as a conductive medium. Moving on, crude oil is mainly a mixture of saturated hydrocarbons that can be separated by fractional distillation. As I said here, the diagram shows in a simplified form the products of the fractional distillation. You have the refinery gases, everything and all. Now state what is meant by a saturated hydrocarbon, they say. Obviously we know that a saturated hydrocarbon is one which contains hydrogen and carbon atoms which only has single bonds. That's right. So obviously what will be the opposite? Unsaturated hydrocarbons. In that case it will be, it has, in case of unsaturated hydrocarbon, there will be, at least one carbon to carbon double bond. Now describe how the fractions in crude oil are separated during fractional distillation. Obviously, they're basically separated according to their boiling temperature. The higher the boiling temperature, the lower the level at which it condenses. The fractionating column has a temperature gradient of 400 degrees Celsius at the bottom and 40 degrees Celsius at the top. And so obviously what happens when the vaporous sample goes up, the hydrocarbon chains present in this vaporous crude oil, which is a shorter chain, which are of shorter chains, they tend to basically melt at higher points, while the ones which have higher chains, they tend to melt at the lower points because they have higher melting temperature. And we know the temperature is high at the bottom compared to the top of a fractionating column. Now, ethene reacts with hydrogen bromide to form bromoethane. So again, they told you to draw the mechanism for this reaction. Again, the same mechanism which we have seen in previously a little while back in two different years, but same questions, same type of question. Again, what happens is that hydrolytic fission, the HBr, or the hydrogen halide, breaks down by hydrolytic fission as it comes in near the carbon to carbon double bond, attracting the, which basically tends to attract the partially positively charged hydrogen atom, and this in turn tends to produce a carbocation as an intermediate form. And then obviously, since it's unstable, the radical which is produced, the bromine radical which is produced, it tends to attack the positively charged carbocation, and hence it produces the stable major product down here. Now, if we move on to the next part, so again, so up to this much for today. So we'll be meeting in our next video very soon. So till then, subscribe to Exam Essentials, and happy revision. And that wraps up part 1. I hope this session helped you and you picked up some key insights along the way. Part 2 is packed with more must-solve questions and will be available in the same playlist, which I have linked in the description. If you found this useful, please like, drop your doubts in the comments, and share it with your study group. Don't forget to subscribe so you don't miss what's coming next. Stay focused, stay consistent, and let's crack this together. Bye-bye.